Okay, now this $1,000 times 1.08 to the t, well, that's a function, okay? So we could write this prominently. We could write, okay, P of t is $1,000 times 1.08 to the t. Now, what is this? Well, it's just a multiple of 1.08 to the t. 1.08 to the t is a power function closely related to the function 2 to the x, or 3 to the x, or 2.7 to the x, which we dealt with about a week ago. So we understand those functions using the same techniques we use with those functions, and my 1 in the 1,000 there is not very clear. It looks like 0, 0, 0. Anyway, you understand what this is. Then we multiply that by $1,000. Well, we just relabel our y-axis. We multiply all our y numbers by 1,000. Or we vertically stretch the graph by a factor of 1,000. Well, if we start with our basic exponential graph, we can label this. Now that's a little tough because 1.08 is a pretty small number. We've done this for 2 to the x, we've done this for 3 to the x, and we've done this for 2.7 to the x. We can do the same thing for 1.08 to the t. So if y equals 1.08 to the t, forgetting the $1,000 for now, we say that 1.08 to the 0 is 1, so right here is 1 on our graph, and we're really familiar with that. So 2 would be here, 3 would be here. Now, after 1 year, we have 1.08 to the 1, and we could attempt to do 1.08 here, but on a scale where this is 1, 0.08 is pretty small, and it's kind of hard to draw that accurately, and kind of hard to project that over to the graph and down to find out where 1 is. So we kind of cheated a little bit. Somebody calculated 1.08 to the 13th. It got something very close to 2.7. Now, coincidentally, that's pretty close to E, and the number that she got was 2.719, and E is like 2.718. Now it, and it's 2.718281828 repeating. So anyhow, it's pretty close to that, but that's just coincidence. There is a relationship with E, but we've got to think about logs to do that, and it's just a coincidence that came out so close to E. Still, we remember what we did to relabel the E to the X graph. We found our 1 here, and then we labeled 2 and 3, and we know that E is about 2.7, so we projected over to the graph and down, and we found where X would be 1. So now we've got a scale for this axis. Well, in this case, 1.08 to the 13th is 2.7. So when y is 2.7, which it is along this line, we hit the graph at the point 13, 2.7, meaning that our x value here is 13. So here's a pretty good graph with a scale where t is 13 here, so 1 would be down here pretty close to 0, 1/13 of this distance. So I posed the question, what's the doubling time? Okay? Well, the doubling time occurs when you get 2 here. You know, you got 1 here, okay, then the value is going to double. If it starts at 1 and doubles, it gives you 2. So we come over from 2 here to the graph, and we come down, and we have our doubling time. So based on the fact that this is 13 and this is 0, I asked people to estimate this number, and the estimate people got was 7, and that's a reasonable estimate. I'd have probably estimated 8, but that's still not exactly right. Okay? So our estimate is that 1.08 to the t doubles when t changes by 7. So it takes 7 years for our money to double. Now we've got this thing called the rule of 72, and so I knew, but just by the rule of 72, that takes about 9 years. And we verified that it should have been 9, but you know, the graph and the scaling and stuff, you know, things aren't done with complete accuracy, so we don't expect this to be right. But this does give us the idea of doubling time. When we double the value of y, that's a doubling time, and every exponential function has its doubling time. That's going to be very important, so I decided to introduce it at this point. Okay. So, again, our 1.08 to the t times $1,000 is an exponential function. If we just graph 1.08 to the t, the graph will have a scale that puts it, that t equals 13 puts it at about 2.7. And then if we want 1,000 times 1.08 to the t, we just relabel it. Instead of 1, we have 1,000. Instead of 2, we have 2,000. Instead of 3, we'd have 3,000. Then we'd have the graph of 1,000 times 1.08 to the t. And in terms of vertical stretches and transformations and stuff, you should understand that part quite well.